So volume of our cone, just like you saw on that demonstration, is going to be 1/3 of the volume of the cylinder, which was pi r squared h. I want to point out to you that this height is the altitude height, not the slant height. So this is the height that goes straight down. You can kind of see in the picture, this is the height that goes straight down from the vertex to the center of the base. This does not use slant height like surface area does. It uses the actual altitude height, okay? All right, so let's look at just a very straightforward example here. Find the volume of the cone, write the exact and the approximate answer rounded to the nearest hundredth. The exact answer means to leave it in terms of pi, okay? So let's look at number 1. Start with your volume formula. We have the 1/3. Go ahead and just bring down your pi. The radius of our base is what, ladies and gentlemen? 5.75. That's the diameter taken in half, 5.75. That is squared. And we need the height, which we are given. This is from the vertex to the center of the base. That's the 15.2. All right, now here's how I suggest you enter this in your calculator, okay? I would suggest that you do the 5.75 squared first. So do this with me, 5.75 squared, hit enter. Then multiply that by 15.2, hit enter. Then divide that by 3. That's doing the 1/3. Emily, what did you get when you did that?
I got 167.5.
Okay, and that would be still in terms of pi. Do we agree with that?
How did you do the 1/3?
Just divided by 3. So after you do 5.75 squared times the 15.2, if you divide all of that by 3, that's multiplying by 1/3. So 167.5 pi, this is what, centimeters squared. And then if you go ahead and multiply the 167.5 by pi, we'll get the approximate answer, which I have as 526.27. You agree with me? Yep, this should be cubed. All right, I'm going to give you about 3 minutes to look at the second one on your own with your table. About 3 minutes for number 2. Go. All right, Justin, talk us through number 2.
I started with the formula,
Okay.
and then I brought down the 1/3 pi,
Okay.
and the radius is 12.4 squared, and the height is 17.7.
Okay. What did you get for your exact answer?
Like my final, or like in terms of pi?
When it says exact answer, that means in terms of pi.
I got 907.18.
907.18 pi.
Yeah.
Do you agree with that? Yeah? Emily? Well, that's because you rounded to the 10th instead of the 100th. And then what did you get for your approximate answer?
2,850 millimeters cubed.
2,850
Millimeters.
millimeters cubed. Good. Questions, comments? Those are our straightforward questions. All right, let's look at number 3. Notice this is going back to surface area, so read that carefully. Find the surface area of this composite figure. That means we're taking 2 or more solids, putting them together. Think about this. If surface area is the area of all of the surfaces, what all is involved here? What's all involved here? What's one surface in that figure? Okay, that lateral area of the cylinder. Maddie, do you remember from the formula the lateral surface part? 2 pi r. Does it have an h in it? 2 pi r h? Is that right? So the lateral surface of the cylinder, I would agree with that. What other surfaces are in this figure that would play into the total surface area? Brittany, what's another one?
A cone.
What part of the cone, though?
The top of it.
Okay, so from the surface area of a cone, what part is that lateral surface? Taylor? Yeah, but like from the surface area formula, what?
2 pi r l. Or pi r l.
Pi r l. What else is involved in this surface area? The area of the
circles on the bottom, two bases.
What 2 bases?
The circle on the bottom and then the circle of the cone.
Is this part of the surface area?
No.
Why not? It's not on the outside. The only base that's part of the surface area is the one on the bottom. This is where the thinking comes in. You have to think about that, okay? So the area of that one circular base, how do we add that part into the formula? Pi r squared. The area of a circle is pi r squared. So let's make a note here. What each part of these represents. That first one is the lateral surface of the cylinder. That pi RL was the lateral surface of the cone. And then the pi r squared was the base of the whole figure, which is the circle. Okay. There is a reason why we have spent so much time developing these formulas. It's so that you guys, the goal at least, is so that you understand what the different parts of each formula means, so that when you see something like this, you can dissect those and use the parts that you actually need, okay? All right. From here, it's really kind of just some plug and chug, but we can go ahead and go through this. So bring down your 2 pi. We're going to leave this in terms of pi. What's the radius of our cylinder? 3. And the height of the cylinder is the 10.
So does the height of the cone not matter?
that first part was the cylinder, the lateral surface of the cylinder. The lateral surface of the cone, the next part, we have pi times radius. What's the radius of the cone? 3. Now we need slant height. We need slant height. You remember from before break how we can find slant height of a cone? Taylor? Pythagorean theorem. So let's zoom in here a little bit on this cone. We have a little right triangle. The height is 4. That radius was 3. I'm looking to find the slant height, which is essentially the hypotenuse of that little right triangle. So I can do 3 squared plus 4 squared equals the lateral height squared, or C. So 9 plus 16 equals C squared. Our slant height should be 5. So make sure that you're using the slant height, not the altitude height, in this formula for surface area. And then finally, for the area of that base, we just need to take pi r squared, where the radius is 3. From here, we'll simplify each part and then add. Again, leaving this in terms of pi.